Speaker, Ilya Baldin, leads RINCY's Network Research and Infrastructure Program. He is a networking researcher with a wide range of interests, including high-speed optical network architectures, cross-layer interactions, novel signaling schemes, and network security. Before coming to RINCY, Baldin was the principal scientist at the Center for Advanced Network Research at the Research Triangle Institute and a network research engineer at the Advanced Network Research Group at MCNC, where he was a team member and a leader of a number of federally funded research efforts. He holds a PhD and master's degree in computer science from North Carolina State University. Today's talk will last about 30 minutes, with time for questions at the end. During the presentation, please type general questions in the Q&A box, not in the chat box. Various members of the Fabric leadership team are on the webinar and will be answering your questions. Thank you and welcome, Ilya.
Thank you. So today we wanted to give everyone an introductory talk and to explain what Fabric is and what it will look like after we've finished construction. First, a little bit of background. Fabric is a project that is funded through NSF Mid-Scale Research Infrastructure Program. The program came about as a result of a number of reviews at NSF, which identified a gap in funding at the mid-scale level, as in somewhere between $20 and $70 million. This program was added, or the idea of a mid-scale research infrastructure was added to the top 10 NSF big ideas, and resulted in a solicitation last year for mid-scale research infrastructure 1 and 2. The two solicitations were different in the amounts in the amounts of provided funding. Well, 1 was capped at $20 million and 2 was capped at $70 million. We as a team proposed to mid-scale research infrastructure 1 and were funded. Our kickoff meeting and the project start was on October 1st. So we've been the project began about a month ago. So what you're about to see is a combination of motivation and vision for where we see the project going. It's important to understand that the way that the National Science Foundation structured this program, this project and the money that we received is intended specifically for construction. There is a separate operation phase that is expected to commence once the Fabric facility has been completed, and that's the time when we expect to have general availability of the Fabric resources to the community. So first, a few introductions. The Fabric leadership team here in the slide includes myself, the Deputy Director Anita Nikolic, Inder Monga, Executive Director of ESNet, Jim Griffin from University of Kentucky, Casey Wang from Clemson University, Dale Carter from ESNet, Tom Lehman from Vernau, Paul Ruth from RINCY, and Zhongming Fei from University of Kentucky. A bit of motivation. The reason why we proposed to develop Fabric is it relates to how particularly the experimenter community in distributed systems and network systems viewed the internet and attempted to revise it over the past few years. As we know, many of us have read and probably have written papers that start with a phrase that sounds something like "internet is starting to show its age." However, we've never had a place to test some of the ideas that emerged out of the community. Some attempts to construct infrastructure that would solve some of these problems and provide experimenters with a repeatable environment where experiments could be launched have been made, notably, of course, Genie. However, when we proposed Fabric, we wanted to look at the core of the network as the main thing that needs to be revised and tested. What we know from the way that the internet was designed was that at the time when the internet protocol and associated other protocols were developed, CPUs were quite slow, and memory was expensive, and so was disks. So as a result, the internet architecture as we know it today came to be known essentially by its main principle, which is the end-to-end principle, where the intelligence resides in the edge, the applications reside at the edge, and the core of the network is quite simple. But however, since the time that this principle was developed and since the internet protocol was designed, the underlying economics of what it means to have processing power and memory have substantially changed. Today, computing power is much more plentiful. CPUs are very fast. RAM is relatively inexpensive. Disk is very cheap. So one of the main premises that we offer to the experimenter community for re-examining is basically this premise that the internet, the core of the network must be stateless. We in fact think that perhaps it is time to revisit this premise and to experiment with some architectures that allow for existence of a larger amount of state within the network. In addition, through the work of many researchers in the community, we now have a number of abstractions for programming packet forwarding behaviors like OpenFlow, P4, ABPF, DPDK, BGP spec, and others. So they allow another dimension in programmability of the core of the network. Also, recent advances in machine learning and AI, in addition to advances in availability of inexpensive GPUs, make it possible to think of the network now as a big data instrument itself, not just transporting large amounts of data, but producing large amounts of data which can be analyzed and used for autonomous control. And of course, as far as the edge of the network is concerned, the emergence of 5G, wireless technologies, IoT, and various flavors of edge cloud technologies also now make it possible for us to re-examine what the internet architecture might look like. It's important to understand that with proposing Fabric, we're not proposing to favor any particular way in which the internet architecture needs to evolve. What we're proposing is an environment in which a variety of ideas about stateful network architectures could be examined at scale. This could mean more control or more data plane state or some combination. It could imply new protocols and applications that directly program the network. If you put a lot of compute power and storage into the network, it now becomes part of the substrate that an application or a protocol can program. And of course, security must be an integral component of any new architectural study. As with many such advances, the ability to store more state of the network can be both used by to improve the security of the network, but also quite obviously increases the attack surface and potentially can make the network more vulnerable. And these questions require study and experimentation in order to determine the right set of balances, checks and balances, or trade-offs within this architectural space. We envision Fabric serving a number of communities and a number of ideas. We think it's important that Fabric can serve to enable the study of new internet architectures and distributed science applications. We also think that Fabric must advance cybersecurity by enabling at scale realistic research. One of the ways that we think Fabric can be useful to cybersecurity community is by allowing peering experimental networks within Fabric with production networks, for instance, on campuses, thus allowing for some amount of opt-in traffic to either be mirrored or traverse a Fabric network, a Fabric experimental network for analysis, for testing new approaches to cybersecurity, and so on. We've partnered with a number of organizations that have HPC resources or other testbeds of different kinds, including PAWR testbeds and NSF Clouds, because we think it's important that Fabric includes as much of the existing substrate that can be used for testing new applications and architectures as possible. We don't plan nor want to recreate the very rich ecosystem of infrastructure that exists in this country for experimenters. Instead, we want Fabric to interconnect many of these resources, just adding another dimension to the possibility of experimentation with infrastructure, with cyber infrastructure. As I mentioned, we think Fabric will allow the experimenting with integrating machine learning artificial intelligence with autonomous network control through the availability of appropriate hardware within key points within the network that experimenters will be able to take advantage of. And finally, and also importantly, Fabric will help train the next generation of computer science researchers by allowing students and postdocs and young researchers access to advanced hardware, advanced concepts, advanced architectures at scale. This slide shows our vision for the core of the Fabric network. It contains the 9 blue nodes that you see in the picture will coincide with ESNet 6 nodes, but it will be distinct and separate from ESNet. This is where we're going to place our Fabric node hardware, which will include switches and servers that will allow experimenters to conduct experiments with stateful networks. The blue links on this map represent dedicated optical capacity that Fabric will have across its core of 100 gigabits per second. And then the yellow links represent what we refer to as a supercore of Fabric, representing a terabit capacity, either 1 terabit or 1.2 terabit. The stars on the map show some of the facility partners that we plan to connect to the Fabric core network. And the call-outs with AWS and Microsoft and Google Cloud logos show the places where Fabric core will appear with Internet 2 to provide access to these public cloud facilities, as we really can't imagine research into applications, network architectures, or protocols that doesn't include a public clouds today. The callouts show some of the regional network providers who are critical to our efforts to connect Fabric edge nodes, of which I will speak shortly, to the core. When constructing the plans for Fabric, we wanted to make sure, as I've previously mentioned, that that we can use Fabric to interconnect the very rich ecosystem of experimental and production cyber infrastructure available in this country to Fabric, such that it becomes yet another asset, yet another resource for experimenters to use to test their ideas. So we started by talking to the representatives from Powder, Cloud Lab, Chameleon, Cosmos. These are PAWR and NSF Cloud testbeds, and make sure that we could connect to them. We then expanded talking to the supercomputing centers, UC San Diego, Pittsburgh Supercomputing Center, and CSA and TAC. And talked to a number of regional providers and network providers, and finally talked to and secured support from the Pacific Research Platform, from US Ignite, and also a number of campuses interested in hosting Fabric nodes. We hope over time that the slide will grow in its density, and the number of edge nodes and facility partners will increase both during the construction phase as well as during the operations phase. A few words about what a Fabric node actually is. As I mentioned, we consider core and edge nodes. We think they will both types of nodes will contain both compute, storage, and programmable network capabilities. They will have programmability using a number of available APIs like OpenFlow, P4, eBPF, DPDK. There will be GPUs available to support machine learning applications. Importantly, due to the placement of nodes in the core of the network, there will be an ability for researchers to interpose compute memory and storage resources directly into the paths of the very fast packet flows, thus allowing the experimentation with stateful network architectures. We think that packet processing speeds will be anywhere. We plan to have packet processing speeds starting from 25 gigabits per second going to 40, 100, and even some number of multiplier on top of 100 gigabits per second. And importantly, we would like to make sure that experimenters have direct access to the hardware available within the nodes, such as programmable network cards, GPUs, FPGA cards, and so on. And the key to Fabric capability is the node placement, of course. The 9 core nodes plus another set of nodes that we plan to place within regional provider infrastructure essentially will create a two-rail topology across the country, which will then interconnect the rest of the edge nodes, both the ones we plan right now, as well as opt-in nodes. We've come up with a name for the edge nodes, calling them Hanks because Fabric is the name of the project. We wanted to have a short name that describes our nodes, and those will be located on campuses, in data centers and labs, and they will allow to provide application-based load to the network, as well as serve as gateways, importantly, to facilities on those campuses that want to be connected to Fabric. That's why it is more correct to think about our edge nodes as more of the kind of on-premises routers than an edge cloud. Importantly, because Fabric is an instrument, it will have significant measurement capabilities. We will have CPU, GPU, programmable NIC, memory, and disk utilization measurements, as well as packet counts, packet statistics across all ports on the data plane interfaces used by experimenters. We plan to introduce a facility called Packet GPS, which will provide precise time and location stamping for all packets as they pass through the core nodes, or through all nodes, in fact. We want to provide packet tracing, classification, labeling, and recording on demand for those experimenters that desire to have that. And we'll also provide some optical layer measurements in parts of the core, both on per wavelength basis, basically optical power, pre and post forward error correction, error counts, and things like that. Those tend to be useful for experimenters that work with cross-layer protocols. This slide tends to summarize our thinking about what Fabric is and what Fabric is not, just so we're clear with our stakeholders about what we're designing. Fabric, first and foremost, is an everywhere programmable network that combines core and edge components that link to many other facilities. For that reason, Fabric is not an isolated testbed. It connects to those facilities. It will also peer at layer 2 and 3 with a variety of networks on demand to allow experiment slices to connect to a wide variety of external resources. Fabric is a multi-user facility. It will support multiple experiments at the same time. It will have federated authentication and authorization system with allocation controls. We envision that over time, this is going to be an evolving topic. Somebody with low-level authorization will be able to access some basic level of resources to perform small-scale experiments, and then those groups or experimenters that require a significant portion of Fabric resources, or perhaps require to run a long-term service on Fabric, will go through an allocation committee in order to be approved for the use of Fabric. And there will be policies devised in order to be very explicit about what the allocation rules are. Fabric is a good place to experiment on new internet architectures, protocols, and distributed applications, and it is also extensible. It's both extensible through adding new facility partners, through peering, as well as the bring your own equipment option. Because Fabric will own some measure of real estate within the core, we anticipate being able to accommodate some number of requests to place additional equipment in our nodes by experimenter groups that have their own hardware. While we do encourage and want to encourage running long-term experiments on Fabric, it is nonetheless not a place for long-term production workloads. Fabric is very explicitly an instrument that is intended for CI experimentation. It is most definitely not a place for real-world protected data. We welcome experiments with developing such applications of Fabric, but we cannot host a PII or any kind of regulated data. And Fabric, perhaps regrettably, is not a fast new pipe for data between its endpoints. There are excellent production networks that the research community has access to, YesNet and Internet 2, and also a set of regionals. And any types of production fast data transfers should take place over those rather than Fabric. Fabric is an experimental instrument. A few more words about the team. In order to validate our design and in order to make sure that what we create is useful to the community, we've teamed up with 4 experimenter groups from SRI, from University of Virginia, from Georgia Tech, and FIU. And we asked them to help us both during the design phase in helping us form the requirements, as well as during the construction and acceptance phase by coming in onto this facility as early users and staging some experiments and leaving some artifacts, perhaps experiment profiles or case studies that will help us qualify the facility for the use by the broader community. And they are intended as samples, as diverse samples of the very vast research space that Fabric enables, including things like security, Internet of Things, machine learning, named data networking, which is of course an ICN architecture, and advanced transport protocols. A few words about the construction timeline. We anticipate the overall, again, as I mentioned, Fabric as funded today is a construction project. We're not yet funded to operate. We expect that funding to come separately. We are in year 1, and we are currently doing the planning, prototyping, and beginning software development and community building. In year 2, we expect, even to be more precise, end of year 1 and definitely in year 2, we will begin the deployment of what we're calling a phase 1 of the facility, which includes both edge and core nodes. We will commence testing and commissioning of those nodes to make sure that they are ready for use as soon as they're deployed. And we will begin working with our science design driver teams to onboard them onto the facility. In year 3, we expect to complete phase 1. This is also when the design driver experiments will likely take place. Some of them may begin a little bit earlier. We'll also begin the phase 2 deployment of both core and edge nodes. And year 4, we plan to complete phase 2 and prepare for operations. I have to say that this is a very conservative schedule. We do expect to have things running a lot sooner than that. However, we wanted to make sure that we also have a schedule that we can keep to, no matter what risks we might face. Fabric community, we are looking to build a very vibrant community of stakeholders. I think unlike many other test beds, we have a number of groups with diverse sets of interests in Fabric, and we want to make sure that they all feel included and they all feel like they're part of this effort. We, of course, have our experimenter community, which is represented by a number of groups and a number of directions. As I mentioned, it's anything from new network architectures to cybersecurity, to new protocols, to applications research, to supporting domain science research through novel distributed applications. We have facility partners, of course, those whose facilities we interconnect or attach to Fabric. We have regional and national network providers who are very critical to this effort. We have government agencies that focus on research in the topics that I described, and of course we have the industry. We will be organizing community workshops throughout the construction period. We want to make sure that our outreach efforts begin early and in earnest. And we want to make sure that the community understands our vision and has influence on our vision, our progress. And we also want to make sure we collect feedback continuously. Finally, we always get questions as to how one might get involved in Fabric. We do have a website. Whatisfabric.net is the easiest one to remember. This is where you can learn more information about the project. You can discuss, for instance, start discussing connecting your facility, your campus, your network to Fabric. You can volunteer to contribute a Fabric node, or you can discuss using Fabric for your research. Importantly, you can click this link on the website, get involved, and it will take you to a form that you can fill out. I think it will follow up with another form, a request to provide more information. And if you could do that, then we will better understand your needs and we'll be able to better target our communications with you in the future. Thank you.
All right, so at this time, we'll go ahead and open it up for questions. If any of our attendees has a question, they can raise their hand and we can put you on live and answer the question live. Additionally, if you click the Q&A button at the bottom of your screen, you can type in a question if you feel more comfortable that way. In the meantime, does Ilya or any of the leadership team, do you want to go ahead and introduce yourselves so that we know who is on the panel and you can meet the panelists?
I'm Anita Nikolic at Illinois Tech.
I'm Casey Wang from Clemson University.
I'm Jim Griffin, and I'm at the University of Kentucky.
Inder Monga, Director ESNet.
All right, thank you so much. And I'm going to go ahead and turn it over to Ilya. It seems like a couple of attendees have posted some questions.
Yes, so there's a question of how Fabric may be different from Genie. Jim, would you like to answer this question?
Sure, there's a couple things I think we can note. First of all, I think if you looked at the topology that Ilya presented there, first of all, one of the things we're trying to do is create a layer 1 topology. These are Fabric-specific resources and Fabric-specific nodes interconnected by layer 1. And while that may not initially seem like a significant difference, it allows us to provide quality of service capabilities over those links, which means that the infrastructure itself, when you're able to reserve, set up an experiment and reserve resources across the network, we're able to actually guarantee that they'll behave the way you expect, which removes a bunch of the uncertainty that happens when you run over an overlay network, where you have cross traffic or other sorts of things that may interfere with your experiment in unexpected ways. That's one of the things. The other is that, in addition to that, we will have different software that will be controlling it, and it will have interconnections that interact with a variety of other data providers or other sources of experimentation. So in particular, we'll be connecting with the supercomputing centers, with several of the other NSF-funded research test beds, such as Cloud Lab or the PAWRs or Chameleon. And this will provide different experimentation that can be directly connected into Fabric, which previously was very difficult or challenging to actually take these types of potential users of new types of programmable technology and integrate them in that sort of way. Can you think of some other things that I'm missing, Ilya?
No, this was good, but I don't know if anybody else from the leadership wants to say something. Okay. Question number 2 was, will the slides be available?
Yes, the slides are going to be available as well as a recording of this webinar.
Next question, are we familiar with the EU's program called NGI, Next Generation Internet? Anita, is that something you would like to maybe talk to? No?
I am not familiar with it.
I am tangentially familiar with it. I think what I can say is that we are looking to build relationships with our European colleagues as well as with our Asian colleagues in order to expand the reach of Fabric to international research communities, whether that would be through federation or other means. I think it's something that's still being discussed. The next question, do you have any specifications for the gear, network compute, especially if it is forward-looking? It would be good so people can plan product development to meet these requirements. The short answer is partial. We are working out on some of these issues right now and doing some of the prototyping. I think that we will have to touch base with our industry friends to make sure what we have is the latest and greatest and most stable that we can offer to the research community. Next question is, will you be sending out information on what will be required to set up a Hank node? Yes, I think that this is, we definitely will be publishing all of our specifications, all of our software will be open and available on GitHub as we firm up particularly the specifications. We will be sending announcements through the mailing list that we're constructing. So if you would like to be kept informed, please visit the website and click the Get Involved button and provide us with as much information as you feel comfortable. And then we will be sure that you're included in all the communications. Sorry, I'm reading. Is there an interest in international partners participating both from hosting the internationally located nodes and international research teams? Anita, would you like to answer that?
Yeah, I mean, definitely we, you know, at NSF, we can't, when we get money from NSF, we can't fund the hosting of things overseas. So we would definitely like partners to extend the network, to do global experimentation. So whether it's hosting or connectivity, definitely experimenters as we begin experimentation in a year and a half. We have on our website, there's a contact form. We're trying to get people kind of in the queue so we can figure out what kind of regions globally are most interested, but for sure, we definitely want international partners.
Thank you. Another question is, what size of data flows, largest bandwidth of a single flow will be available on the supercore? Inder, I wonder if you could answer that. You're muted.
Hey, thank you. I think that is our intent, both from the DTN and the compute pool, is to support multi-100 gigabit flows on the supercore, on the terabit supercore. But there's also a 100 gig dedicated core with compute that can easily saturate that 100 gig link. A lot of it will depend on the node design that we're in the progress right now and as technology improves. So I think, and also the end nodes, we're connecting to the supercomputing centers that may be able to push a lot of data as well. So I think based on both of those, we should be able to fully utilize the supercore in the time frame by the end of the 4 years of construction. Anybody else from the panel want to add to it?
I think this is great. It's accurate. Do we have any more questions? Are there questions about the CC star proposal? So let's talk just a tiny bit about this. Anita, do you want to talk about the CC star?
Sure. So in the latest CC star, which came out, I don't know, a week or two ago, in area number 3, it exclusively calls out Fabric. Area 3 is the more kind of research focused area of CC star. If there's some experimentation, or it's not your buy equipment for the campus, but it's more the researchy area. If anybody is applying to that area, or there are some interesting research experimentation to give you a letter of collaboration, if you would, if you see there are needs in Fabric that are kind of similar needs to what you might be proposing, we'd be happy to look at a one-pager, provide you a letter, figure out how we can collaborate. NSF is encouraging that. So it's kind of good for both of us to get community early on board and also for you to get our support. So what you would do is send it to, I think we have a general mailbox, right, Ilya, for that?
Yeah, I think contacting the info at fabrictestbed.net is the right way to go.
So shoot us an email, say we're thinking of applying to CC Star Area 3. What does this mean? How should Fabric be involved? And we will definitely have a follow-up conversation with you.
Yep. Yeah. And if you know us personally, you can send it to us. We'll make sure that the leadership team looks at it. Either way is fine, but I think you will be given an email address momentarily in the chat. Yep. How will Fabric fit in with PRP, NRP? Jim, do you think you would want to take that? I can take it, but I thought maybe you'd like.
No, why don't you go ahead? We've had more conversations with them. So.
All right. So we are partnering with them. There is a fairly obvious mismatch in timelines in that, at least as it stands today, the funding for TNRP, for instance, I think is running out next year. We do have, I think, some overlap in the communities that we serve, and we would like to the extent possible, connect existing PRP, TNRP facilities to Fabric so that their users get yet another resource which they can use for their experimentation. One thing I think to note is that PRP, TNRP are fairly explicitly focused on serving CI needs of some number of domain sciences. Fabric is a little bit different in that it is funded to support SciSci activities. We do welcome and we are interested in supporting CI experiments related to domain science problems, but it's important that the computer science angle of it is always taken into account. I don't know if any of the leadership team want to add anything to this.
I'm just going to jump in and say, like, if somebody wanted to explore different data transfer mechanisms between PRP nodes to make it more efficient to move data, you could use the Fabric testbed as a mechanism to do that. For production flows, I think, as Ilya pointed out, we hope you use your existing RNE network for that purpose.
Are there any other questions from the attendees? Wanted to ask the leadership team, perhaps you wanted, there's a question. Will Fabric always be experimental and no production? Yes, that's correct. I think we can, this is not a black and white separation, right? So I think I mentioned we would welcome running experimental long-term services using Fabric. However, there's a line there that can be crossed that we don't want to cross, where using Fabric when Fabric becomes a production resource on which a large population of users relies. This is the point where we would want to discuss how to transition a service like that to an existing production facility or network.
So I think, Ilya, what I can qualify what I've heard NSF program, I just say pre-production workflows are okay.
Yes.
And just to add to that thought, the one important aspect Fabric is exploring is how can we take production workflow and then from a scientific perspective understand its characteristics. And that's why we interface Fabric with production networks so that you may have production traffic flows that you have been sending across your original network for a long time, but there may be opportunities to understand it better for further advancement. That's where you can consider taking an existing application and traffic and then configure it such that it traverses Fabric, leverages all the services available on Fabric so that you can conduct it from a research perspective to identify opportunities.
Thank you, Casey. So another follow-up questions. Once experimentation pre-production is validated on Fabric, then what? I think this is the time to start conversations with ESNet, start conversations with Internet 2, start conversation with other large-scale facilities, depending on how this particular CI experiment or pre-production workflow is set up, to transition them to those production infrastructures. I mean, in part, Fabric is meant to serve as a place to figure out designs for future scientific networks, among other things, right? So if the outcome of your experiment is to tell Internet 2 or ESNet, look, we've received great results out of this. This needs to become a production service. I think I may be putting words in Inder's mouth, but I think he would welcome such an outcome.
I can't say anything, words in my mouth. I agree with you, Ilya. I think this is a fine line, of course. And I'm just going to give an example. Say you have an edge computing application that really enhances a scientific workflow. What the Fabric infrastructure is going to provide you is a mechanism to prove that at scale, you get the kind of benefits that you may have imagined in a simulation or on paper or theoretically, and you can prove that experimentally for a pre-production workflow that edge computing mechanism, whatever you came up with, can really enhance the output performance production of that workflow. And that becomes kind of a case that none of the production networks can deny and then can work with you to see how to implement that.
Sort of follow on that. I mean, in some ways, one of the things that Fabric provides that is not possible in general today is an everywhere programmable network. That is, you can program the core, you can program at the edge, you can program inside the core, you can program at the very far edges. And as a result, you can rethink the way you design applications. And in some ways, because of this, it's been a chicken and an egg problem that if you don't have the facilities to actually experiment with these new types of application designs, they aren't going to arise. At the same time, once they are there, that puts some pressure on infrastructure to be able to support those types of applications. So we would expect that this might actually help sort of break that cycle. And hopefully allow, as new applications arise that haven't been designed before, that they might actually generate a push for new types of infrastructure.
Another question is, what measurement capabilities will Fabric have, and will the data be made available? I don't know if anybody of the leadership team wants to take that, or if I should.
Well, I can start, Ilya, and you can add some additional capabilities. But Ilya mentioned there that one of the things that we're hoping to have there is relatively detailed measurements of experiments that experimenters can deploy and integrate into their applications. We also hope to be able to provide infrastructure monitoring capabilities that measure the infrastructure itself that may potentially be made available. We have not yet decided exactly what the policies will be for making data available. We're still working through some of that, but we do expect that the idea is to try to make as much data available as possible.
I think that's a good answer. There are examples of what we want to provide. I gave them in the beginning of the presentation. I think some additional examples might include measuring traffic at those dynamic peering points that I mentioned, for instance, at layer 3. Of course, we want to allow experimenters to measure their entire experiment to the extent as possible. With the availability of data, I think this is still a question we're discussing. We I think we want to encourage, at the very least, the experimenters to share their data with the community. How it will work out policy-wise, I think we will. We are discussing that question actually right now.
So I think, Ilya, it's a good time to say that we are seeking input from the community as well. I mean, this is a test bed for the community, and we will be organizing a workshop sometime next year. And Anita, maybe you can speak to that, to get input from the community. So it's not, again, I think these are great questions, but for some of them, we will take guidance from the members of the community to figure out how to tackle them and what's the best way to solve those issues and what's needed.
Anita, did you want to add something?
I was reading the next question. Yeah, our plan is to host a, we call it a community visioning workshop, probably like next April or May. We'll be putting out, we're going to need to figure out where and exactly when, but that's where we want to really run past to the community, which we are going to define very broadly, from campus to researcher to industry, what we think we've heard, what our initial design is, and before we get to deploying and saying these are our capabilities, we need and want your feedback. So between now and then, if there are, I mean, particularly for measurement, this is something I'm very interested in, really hearing specifics, or for experiment setup, please tell us so that we can build that in. But look for that workshop, that'll be in spring sometime.
Yeah, I second what Anita just said. And just to reiterate, we really would like for Fabric to be a community resource, a community-driven resource. We want to ask questions, and we'd like to get, detailed answers from you, so to make sure that what is built is useful in the long run to the community. Another question, at the beginning of the webinar, you mentioned two initiatives put forward to NSF, $70 million and $20 million. Was the $70 million initiative also approved, and does it relate in some way to Fabric? So the answer is, I don't know. I believe that the mid-scale RI2, which is a $70 million one, is still being in the proposal stage, as in it's being proposed to. We are in the $20 million category, and MSRI2 has nothing to do with Fabric. We were in the first wave of MSRI1 awards. I believe that the solicitation for them will be biannual. So if you're interested in proposing your own idea, I believe your next opportunity will come in about 1.5 years. Any other questions?
If you're at SC, we will be there. We'll have stickers and maybe some t-shirts.
We'll definitely have stickers, and maybe for a few lucky attendees, we might have a t-shirt or two.
Come by and find out.
Yeah, so I guess the Renzi, find the Renzi booth. What is the booth number?
781.
The booth number is 781. Please come talk to us if you want to just chat with us in person. There's going to be a number of us from the leadership team present at the conference. We're happy to talk. You will be able to
TechX too.
I'm sorry?
We'll be at TechX as well.
We will be at TechX as well. At SC, you will probably be able to spot us by our fashionable Fabric t-shirts. It should be easy to tell. There's a thanks, folks. We're looking forward to participating. Thank you. As I said, please think about what Fabric might mean to you, to your community, to your own research, and let's talk. This is the right time to talk. We're in the planning phase. What we showed today is a plan. It is not an implementation yet. As Anita referenced, we want to hear feedback. We want to be able to change those plans if that's what the community wants to see. Thank you, everyone.
All right, well, thank you, Ilya and the Fabric leadership team, for presenting this talk and answering questions today. We appreciate your time and that of our attendees. Please make sure to visit www.whatisfabric.net to learn more about Fabric and visit the Get Involved page if you would like to connect with us. Thank you all and have a wonderful rest of the day.
Thank you.
You.
Thank you.
Thank you.